This is a brief review of this week's notes on calculating elasticity and how elasticity changes along the demand curve. First of all, I want to remind you that elasticity is not the same thing as slope. There are three specific reasons for that. Number one, when you calculate slope for a line like this would be the same all the way along the curve. Elasticity is actually going to vary along the curve. It's going to vary from an elastic region here to a unit elastic region here to an inelastic region at the lower right-hand portion of our diagram. Second thing is, when you are calculating slopes, you do not use percentages. And if you look at our formula, you will see that we are talking about the percentage change in quantity demanded divided by the percentage change in price. The third piece, of course, is that rather than calculating the change in y over change in x, we're calculating change in x over change in y, the change in quantity demanded divided by the change in price. So change in x over change in y. So for three reasons, elasticity and slope are not identical concepts. When we are calculating elasticity, what we are asking ourselves is how responsive is a change in quantity to a change in price. So if we move from point A to point B along this curve, what we're asking is, if the price drops from $8 to $7, if the price drops by $1, how big is the impact on the change in quantity? And in this case, the price drops by $1, quantity increases by 1. But proportionally, this is enormous, right? Because the price has dropped by a fairly small percentage, around 12, 13, 15%. But the quantity demanded has doubled from 1 to 2. And we're talking about the relative magnitude of these changes. Okay, so how do we calculate this? First of all, in general, we're talking percentage change in quantity demanded over percentage change in price. To be more specific, we're going to add in absolute value because otherwise our elasticities of demand would turn out to be negative. And we don't want to use negative figures. We're interested in just looking at the magnitude. Second of all, we're going to use this midpoint formula because we don't want there to be a difference if we calculate from A to B compared to if we calculate from B to A. And normally, when you're calculating percentage changes, the denominator is going to be the original point. So if we were moving from A to B and we were just going to look at what is the percentage change in price, we would say 8 minus 7 divided by 8. But if we were moving from B to A, we would say 7 minus 8 divided by 7. When we take absolute value, we would take care of the numerator, right? But the denominators would still be different. And to make up for that, instead of using 8 and 7, economists agree to use the midpoint. So in both these equations, we would substitute 7.5 instead of 8. That way, we end up with the same calculation for percentage change in price, regardless of whether we're going from A to B or from B to A. So this formula that we see here is really not as complicated as it seems. All we're doing is we're talking about the change in quantity as we move from A to B. We're saying 2 minus 1 divided by the midway point. So 1.5. 2 minus 1 divided by 1.5. Okay, so the numerator here is going to be 1 over 1.5. Right, and the change in price is from 8 to 7. Okay, so 8 minus 7 divided by the midpoint, which is 7.5. So our denominator here is 1 over 7.5. Okay, you can use your calculator to calculate that, or if you understand that you can take 1 over 1.5 and flip the fraction in the denominator, you would multiply by 7.5 over 1, and you come up with a coefficient of elasticity of 5. Okay, so that's the formula for calculating coefficients of elasticity. We normally don't need to calculate those, but it is good practice. You should, if you use this formula, I'm going to show you the next slide. If you use this formula in these three portions, and I would really recommend practicing it if you're not sure, you should come up with a 5 here, a 1 here, and 1/5 here, or 0.2. So elasticity will change along the curve from a more elastic region where the drops in price are going to be relatively small, 8 to 7, 7 to 6, and the increase in quantity is going to be quite large, 1 to 2, 2 to 3, to the inelastic range where the drops in price are going to be dramatic. $2 to $1 is a huge drop in price, 50%. However, the increase in quantity is relatively minor. What we will use more typically to be able to calculate this is the total revenue test. The total revenue test, I'm trying to move this down a little bit. The total revenue test is using a calculation of total revenue and comparing what happens to total revenue in response to a change in price to figure out elasticity. So if we look at the price of 7 here, the total revenue at a price of 7 is the price of 7 times the number of units sold. So a price of 7 times a quantity of 2 gives us a total revenue of $14. The rectangle in blue represents the $14. What would happen to total revenue if the price dropped to $6? At a price of $6, people would be willing to buy 3, so $6 times 3 gives us a total revenue of $18. What this total revenue test is telling us is that when the price dropped from 7 to 6, total revenue increased from 14 to 18. If price drops and total revenue increases, that is a test that tells us that we are in the elastic range of the demand curve. If price drops still further to 5, we'll sell 4 units of output, and the area of this square is 20. So again, we're still in the elastic region. Prices dropped again, total revenue increases. If we do this another time, drop the price to 4, we'll sell 5 units of output. Now our total revenue is again 20. Price dropped, total revenue stayed the same. We can define this as the unit elastic range. And finally, let's look at what happens when we drop the price one more time. Drop the price to $3. We sell 6 units of output. The area of this rectangle is 18. We decreased the price, the total revenue dropped. So now, when we move from $4 to $3, we know that we have entered the inelastic region of this demand curve. To summarize, you can look at these elastic, unit elastic, and inelastic terms each in several ways. In general, we say the change is elastic when a small change in price creates a large change in the quantity demanded. Another way of looking at it is to say that the coefficient of elasticity is greater than 1. And while you won't need to calculate that, you will need to recognize that. So if you are told that a particular product has an elasticity coefficient of 1.8, you should be able to recognize that as elastic. The third way, and this is the test that you are going to be expected to apply, is the total revenue test. If the price goes up and the total revenue goes down, we can conclude that it is elastic. Likewise, if the price goes down and total revenue goes up, we would conclude elastic. Okay, unit elastic, the percentage change in price and the percentage change in quantity are equal. The coefficient is 1, and in this case, any change in price, whether price goes up or price goes down, total revenue is constant. Finally, inelastic is defined as a large change in price causing a relatively small change in quantity demanded. The elasticity coefficient is going to be less than 1, but remember, we're talking absolute values, so we're really talking about between 0 and 1. So if you're given an elasticity coefficient of, say, 0.22, you would conclude that the demand is inelastic. The total revenue test, if the price goes up, the total revenue goes up. If the price goes down, likewise, total revenue goes down. That will be a sign that it is inelastic demand.